Okay. Date 2nd September 2024. Time is this. And day 117. New folder. Day 117. So today we are going to see a next Node.js concept. So we have studied modules in the last session. What we have studied? Modules. What do you mean by node modules? Importing, exporting. That part we have seen. Now we are going to see something called as, what do you mean by buffer? What do you mean by buffer? So when you talk about the buffer, if you go here, learn. Okay, before moving ahead to the buffer, let us try to understand the asynchronous programming in the Node.js. Actually, I wanted to cover this today, asynchronous, but we have already discussed this part. What do you mean by asynchronous programming? Fine, let's try to cover both the things, buffers and the synchronous thing. But if it doesn't cover, we will just complete the asynchronous flow. So when you talk about the Node.js, at its core, the JavaScript is designed to be a non-blocking on the main thread. This is where views are rendered. You can imagine the importance of this in the browser. When the main thread becomes blocked, its result is infamous freezing that users dread, and no other events can be dispatched, resulting in the loss of the data acquisition, for example. So if you remember, we have discussed what you can say promises in the JavaScript. One of the way of handling the asynchronous programming is nothing but what? The promises. So if you see here, promises is the feature of the JavaScript. Promises are nothing but what? The feature of the JavaScript with which you can handle the asynchronous programming. Now let's have an overview of the blocking and the non-blocking once again. This overview covers the difference between blocking and non-blocking calls in the Node.js. This overview will refer to the event loop and libuv, but no prior knowledge of those things are required. No problem. The readers are assured they have basic understanding of the JavaScript language you have, and the Node.js callback pattern. We'll talk about this. The IO refers primarily to the interaction with the system disk or the network supported by the libuv. What do you mean by blocking? Blocking is when the execution of the additional JavaScript code in the node process must wait until the non-JavaScript operation completes. Blocking is when the execution of additional JavaScript in the Node.js process must wait until the non-JavaScript operation completes. JavaScript code has to wait until non-JavaScript operation completes. This happens because the event loop is unable to continue running JavaScript while a blocking operation is occurring. Means JavaScript program has to wait until you write the file. In a Node.js, a JavaScript that exhibits the poor performance due to the CPU intensive rather than waiting on a non-JavaScript operation such as an IO isn't typically referred as a blocking. Isn't typically referred as what? Blocking. The synchronous methods in the Node.js standard library that uses the libuv are most commonly are the blocking operations. Now, if you see here, const fs require node colon fs. So we have imported here we have imported one node package file system. Fs stands for the file system. Okay. Now here if you see, if you write something, if you write something after this read file sync, when you say sync, it is a blocking operation. Fs read file sync, right? Fs read file sync. If you write any JavaScript code after this line, if you write any JavaScript code after this line, because of this non-JavaScript operation, it will wait. Okay, it will wait. Means it will block the execution. Block here until the file read is complete. Until you read this file, nothing is happening. That's why it is a blocking. An equivalent asynchronous, if you see, you have passed a lambda or the arrow function as a second parameter. Arrow function as a second parameter. Read file is a method, and you pass the second parameter as this arrow function with the error first approach. First thing is error, second is data. The first example appears simpler than the second, but has a disadvantage of the second line blocking the execution of any other JavaScript. As I said, it will block the execution at this line. If there is a 1 GB of the file, until 1 GB read completes, nothing will happen. Okay, nothing will happen. Now, where it is going to impact? Whenever JavaScript execution in a Node.js is a single threaded. So concurrency refers to the event loop. What is the event loop? We will see. Event loops capacity to execute the JavaScript callback functions after completing the other work. Any code that is expected to run in a concurrent manner must allow the event loop to continue running as non-JavaScript operations like IOs are occurring. Any code that is expected to run in a concurrent manner. Concurrent means what? Simultaneously. You are writing or reading 10 files together. You are writing or reading 10 files together, which might hamper the execution. Just a minute. Yeah, hi. So, concurrency and the throughput. Now consider that you need to write 100 files and one file is of the 100 GB. It will take a lot of time to execute this. So it will take a lot of time to execute this if you go in this way. So you are writing hundreds of such lines because you need to read the 100 files and one file is of the 100 GB. So this will take a lot of time. This will take what? Lot of time. And it will block the thing until this gets executed, right? So they have given the example. The JavaScript execution in the Node.js is single threaded. So concurrency refers to the event loops capacity to execute the JavaScript callback. Event loops capacity to execute the JavaScript callback functions after completing the other work. Any code that is expected to run in a concurrent manner must allow event loop to continue running as a non-JavaScript operations like IOs are occurring. One example, I want to read the 50 files together, that will create the problem. The event loop is different than the models. The event loop is different than the models in any other languages where the additional threads may be created to handle the concurrent things. But in Node.js, there is one concept called as event loop. Okay. And what is that event loop? Let us see. Let's go here. Let's go here. Node.js event loop, very important thing. Java, your interview question. The event loop is what allows Node.js to perform the non-blocking IO operations. The event loop is what allows Node.js to perform non-blocking IO operations despite the fact that a single JavaScript thread is used by default. By offloading operations to the system kernel whenever it is possible. The event loop, here is the definition, is what allows Node.js to perform the non-blocking IO operations. Non-blocking IO operations despite the fact that single JavaScript thread is used by default. Despite the fact that the single JavaScript thread is used by default. By offloading operations to the system kernel whenever possible. Since most kernels are multi-threaded, they can handle the multiple operations executing in the background. When one of these operations completes, the kernel tells Node.js so that the appropriate callback may be added to the poll queue to eventually executed. We will explain this in the further in the topic. This is very important thing. Since the most modern kernels are multi-threaded. See, what do you mean by event loop? The event loop is what allows Node.js to perform the non-blocking IO operations despite the fact that a single JavaScript thread is used by default. Thread is nothing but what? Something which performs the operations despite the fact that a single JavaScript thread is used by default. How? By offloading the operations to the system kernel a layer of the operating systems whenever it is possible. So Node.js gives or assigns the extra work to the operating system kernel, right? To the system kernel whenever it is possible. Node.js application says that I will not do this thing. Who will do this thing? Kernel will do this thing. Since most modern kernels are multi-threaded, they can handle multiple operations executing in the background. Since the most modern kernels are multi-threaded, they can handle multiple operations executing in the background. Most of the operating system kernels are multi-threaded. So they can handle these operations in the background. When one of the operation completes, kernel notifies the Node.js by calling the appropriate callback. May be added to the poll queue. What is the poll queue? We will see, to eventually be executed. Okay, event loop. When the Node.js starts, it initializes the event loop, processes the provided input script, whatever JavaScript you are going to provide, that would be getting processed, right? Which may make a async API call, schedule the timer, or call process dot next tick, then begin the processing in a event loop. Okay, see now what is going to happen. The following diagram shows the simplified overview of the event loops order of the operations. So each block is referred as a phase. Okay, phase of the event loop. Each phase has the FIFO queue. This everything is a phase, and each phase has a FIFO queue. Each phase has a FIFO queue of the callbacks to execute, while each phase is special on its own way. Generally, when the event loop enters a given phase, it will perform the operation specific to that phase. Then execute the callbacks in that phase queue until the queue has been exhausted. Okay. The maximum number queue has been exhausted, or the maximum number of the callbacks are executed. When the queue has been exhausted or the callback limit is reached, the event loop will move to the next phase and so on. Okay, timers, pending callbacks, idle prepare, poll, check, and the close callback. Right here, if you can see phase wise overview. Timers, this phase executes the callback scheduled by the set timeout and the set interval. Pending callbacks executes the IO callbacks deferred to the next loop iteration. Executes the IO callbacks deferred to the next loop iteration. Idle prepare only used internally. Poll, retrieve the new IO events. Execute IO related callbacks. Almost all with the exception of the callbacks, the ones scheduled by the timers and the set immediate. Node will block when appropriate. Set intermediate callback is invoked over here. Check phase, set immediate callback would be checked, invoked over here. Close callback, some close callbacks like socket.on, like you'll get to know, that are executed over here, right? So this is nothing but little overview of what you can say. Well, whenever we are going to execute, whenever we are going to execute our applications, that we will see. But what you need to remember, timers, whenever you use the function set timeout or the set interval, set timeout, whenever you use the set timeout and set interval, do you remember these functions? Do you remember these functions or not? Set timeout and set interval.
No.
We have studied this in the DOM manipulation, right? We have studied this in the DOM manipulation. Hello? Whenever we change the color, if you remember, we have changed the color dynamically.
Yes.
We have changed the color of the div dynamically. At that time, set timeout set interval function we have seen. Correct?
Yes.
So timers, pending callback, these are the phases. In the timers phase, set timeout, the callback scheduled by set timeout and the set interval are executed. Pending callbacks, whatever executes the IO callbacks deferred to the next loop iteration. Pending callbacks executes the IO callbacks. So if you see in a pending phase over here, they have given pending callbacks, right? This phase executes the callbacks for some system operations such as the TCP errors. For example, if the TCP sockets receives econ refused when attempting to connect with the NIX systems, so such callbacks are executed in the pending callbacks. Okay, idle prepare only used internally. Idle prepare. Now, if you see the poll has the two main functions: calculating how long it takes, how long it should block and poll for the IO, then processing the events in the poll queue. When the event loop enters the poll phase and there are no timers scheduled, one of the things will happen. If the poll queue is empty, the event loop will iterate through the queue of the callbacks, executing them synchronously until either the queue has been exhausted or the system dependent hard limit is reached. System means operating system. If the poll queue is empty, one of the two things will happen. If poll queue is empty, one of the two things will happen. If the script have been scheduled by the set immediate, the event loop will end the poll phase and continue to the check phase to execute those scheduled scripts. If the script have not been scheduled by set immediate, the event loop will wait for the callbacks to be added in the queue so that it will execute immediately. Once the poll queue is empty, event loop will check for the timers whose time thresholds have been reached. If one or more timers are ready, the event loop wrap back to the timer phase to execute those timers callback, right? So if you see timers phase, pending callbacks, idle, poll, and the check. Poll and what? Check. When you say check, This phase allows person to execute the callback immediately after the poll phase has completed. If the poll phase becomes idle and the script have been queued with set immediate, scripts have been queued with the set immediate, the event loop may continue to check the phase rather than waiting. Set immediately is actually a special timer that runs the separate phase of the event loop. It uses the libuv API to schedule the callback to execute after the poll phase has completed. Generally, as the code executed, as the code executed, the event loop will eventually hit the poll phase, where it will wait for the incoming connection requests, etc. However, if the callback has been scheduled with set immediate and the poll phase has become idle, it will end and continue to check phase rather than waiting for the poll events. So close callbacks are easy. See, this is a little bit theory, but before heading to the actual Node.js concepts, we need to know this very important thing. Okay. Close means what? Whenever you open the file and there is a close call, there are something closure related things. And if you want to, and whenever Node.js enters into those things, this would be getting called. If a socket or a handle is a code abruptly socket.destroy, the close event will be emitted in this. Close event will be emitted in this phase. Otherwise, it will be emitted via process.nextTick thing. Set immediate versus set timeout. So these are two functions, set immediate, set timeout, are similar, but behave in a different ways depending on when they are called. When they are called, see this set timeout console.log this, and here you have set the 0. The set immediate is designed to execute the script once the current poll phase have been completed. Set immediate is designed to execute the script once, only once, the current poll phase completes. Set timeout schedules a script to be run after a minimum threshold in MS has elapsed. Set timeout schedules a script to be run after a minimum threshold in MS has elapsed. The order in which timers are executed will vary depending on the context in which they are called. If both are called from within a main module, then timing will be bound by the performance of the process. Okay. For example, if you run the following script, which is not within the IO cycle, the main module, this one, the order in which two timers are executed is non-deterministic, because when this would be executed and when this would be executed, as it is bound by the performance of the processes, right? Set timeout, set immediate. So when we don't know what is going to happen exactly. Well, these things are important with respect to the event loop. So this page you may read again. This page you may read again. I will give you reference of the whenever we actually type the code, all these things I am going to revise once again. I am going to revise all those things once again so that you will get the references again and again. Okay,
Okay.
fine. Let's call it for a day. We'll meet tomorrow.
Okay.
Yeah,
Bye.
bye.